Hi, good afternoon. Welcome to today's webinar about CompoSIDE and yacht. My name is Lorenzo Bossi. I'm the Sales and Marketing Manager here at CompoSIDE. And joining me today is Jonathan Evans, our Application Engineer.
Hello everyone.
So today's webinar is the object of advanced design of composites, parts and components for motorboats and sailing yachts. Particularly what we're looking at is the design of bulkheads and penetration reinforcements. Just a brief reminder, today is the fourth and last webinar in this marine series. We started beginning of the month introducing the features and capabilities of CompoSIDE and yacht, our scantling module. We then looked at how to design some of the main or typical vessel structures, including keels and engine girders. And last week we looked at detailed design and idealization of components such as rudders and keels. Today, as mentioned earlier, we'll be focusing primarily on the bulkheads design with some advanced laminate and geometrical operations on the bulkhead in order to really optimize those components in terms of their structural performance. The agenda for today is once again to provide a brief introduction to CompoSIDE and the main modules which is part of the suite. We'll then jump into the live demonstration, providing you with an example of the advanced bulkhead design, taping and local reinforcement, creation of rules and local coordinate systems, and also the automated reporting. On the right-hand side of your screen, there should be the GoToWebinar panel. There is a questions little tab which allows you to type questions if you have any. Please feel free to type those any point during the presentation, and we'll take the time at the end of this webinar to answer those questions. Okay, so if you are new to CompoSIDE, really what it is an integrated environment. It allows you to define projects and users, and inside those projects to create your vessels or your components. There are also dedicated modules to materials management and material data. So materials can be fibers, cores, plies, but also extended classical laminate tools to allow you to build and analyze your own laminates. Materials and laminates can be used both in scantling operations, so we're looking at analytical tools and apply them to beams and panels, but also to perform detailed engineering design through 2D section design or 3D design and FEA. All the suite is integrated with a reporting engine, so you can, at the click of a button, create scantling reports, you can create laminate reports, panels reports, and also detailed or summarized bill of materials for the entire components within your project. So you can have an entire vessel that you've been designing, can instantly create a bill of material to know exactly how much material, what's the weight and the surfaces needed, and how much is it going to cost to source those materials to construct your vessel. So all those operations are integrated in a suite of modules. The first one is project space, which is where you create new projects, assign users who have access to the specific projects. But you can also customize safety factors, failure settings, or bill of material settings. What I mean by bill of material settings is the usage and wishes factors that are applied to the total areas and weight of materials in your components according to a specific manufacturing process that you select. And you're also able to basically manage all the materials, plies, laminates, products, beams, panels, and also loads and reports that are within your project. CMDB stands for CompoSIDE Material Database, and Plygen is a micromechanical module for creating plies. What those modules allows you to do is to build your own material library. So with CompoSIDE we supply you close to 60 generic materials, but as a user you have a private library in which you can basically add or modify and manage all your own materials. You're able to review the materials, review properties for calculation, perform material comparisons via tables or normalization charts, and also material selection through a number of options such as scatter plots, search by specific properties, such as the density, for example, moduli, and so on. All the material are organized in libraries. So there is, I mentioned, a private company library. This is what is for you as for you and your colleagues as a client of CompoSIDE. And then you have the project materials, which are basically all the materials that are used within your own project. Now, if you're looking particularly for material data, we do offer an add-on, CMDB add-on, which is otherwise known as the CompoSIDE Material Library, and is a very comprehensive material data library containing 1,250 plus materials, which include cores, fibers, adhesive, resins, but also wood, playwoods, plastics, and metals. So very often our clients tend to do a side-by-side comparison of metallic versus composite structures to evaluate the benefits, the costs, and the structural performance of those components side by side. And alongside the base materials, there are close to 900 plies, which are fully characterized for you to use in your design. That means having access immediately to all the data needed to perform engineering activities without having to invest heavily in testing activities at the very beginning of a project. All the data is manufacturer independent, so what you will have access to are characteristic values that have been compiled from multiple sources, including published data, internal testing, external testing, and so on. All the materials are fit for design and FEA, so that means that you can do your hand calculations, analytical calculations, or full 3D FEA calculations with the data that is provided. There is nothing missing that will prevent you to do that. And you can also export material data, plies, and laminates to FEA tools such as ANSYS, Mastran, OptiStruct, Radius, or export it to Excel, but also call in API so you can create your own custom scripts to create some routine on optimizations or material data formats that you are required to use within your processes. So I mentioned the idea and the concept of material libraries. So what you see here is example of, for example, what is my company materials. So this is the private library to which only you and your colleagues have access with a number of materials. As I said, we give today close to 69 materials. The CS material library is the add-on, so if you're looking to populate your own library with those materials, they're all sorted in this folder. By just registering to the trial, you do have access to the 70 materials, but you're also able to browse all the materials that are within the CS material library. Can't use them in projects, but you're able to see what is available in case you would like to use them. And then for each project there is a sub-selection of materials, so we just drag and drop those from the company material or the CS material library into our own active project materials, so we can work with a clean subset of materials instead of having to go through the 1,500 and plus in total. And alongside those you can create sub-selections. It can be by type of material, it can be by component, using your vessel or so on. LaminaSpace is the tool dedicated to the extended classical laminate theory, and it allows you to basically create laminate families, including the concepts of base and sublaminates. We'll give you a couple of examples on how to use base and sublaminates later on in the presentation. But I think for now, what is important is that the functionalities of this model is to allow you to basically create, store, review laminates. And in terms of engineering reviews, you can review engineering constants, allowables, true thickness shear, sandwich stability, analyze loads, and also coefficients of thermal expansion. So all in all, LaminaSpace is an environment where you can manage your laminates, review and store them. You can create automatic detailed reports, but also directly create shells or export laminate tables to Excel. and as I mentioned earlier, 2 FEAs such as ANSYS, Nastran, OptiStruct, Radius, and so on. Section space is a 2D and BIM modeling environment. It allows you to create geometries by either modeling them directly into the environment or importing the XF or point data. The sections are defined as either thin-walled or solid sections, and there are contextual menus which basically allow you to just right-click on any of the sections part and allocate laminates, materials, or modify those as you see fit. Section space also provides you with a fairly detailed view of the section properties and allows you to perform load capacity analysis to review the allowable loads and the reserve factors. So section space in summary is a two-dimensional design tool which allows you to quickly create and design your profiles, analyze them, and optimize your laminate stake-ups. FE space is the three-dimensional modeling in FEA. Similar to section space, you can create or import or directly model your geometries. It also features a finite element analysis module. We have an automatic mesh generators which allows for manual refinements for the areas of most interest. And in terms of solver capabilities, you can perform linear, backlinking, or model analysis. All the analysis jobs are sent to the CompoSIDE server. They are solved online in a matter of 10-15 seconds. And you can basically also use that system to store your analysis results, so that will directly link it to the model, link it to the laminates, link it to the materials. So you have everything in a single environment without having to go through files. If you take a project that you did 6 months ago, just remembering where all those files are can be quite tedious of time. And FE space also allows you to create, to manage your topology systems. So you can have a section that you extrude and bring into and create a BIM model into FE space, and you're basically able to make a global analysis on that model, as you can see here in the bottom right. And then by just going back to section space, this is automatically linked to the linking the two environments. You can actually perform cross-section optimization, laminate optimization on the cross-section itself, optimize until you reach a level of reserve factor you're satisfied with before then pushing that update back to FE space, and all of the beams that were associated to the section are automatically updated. So you just have to perform a very last global analysis in order to confirm everything is fine. One interesting concept in FE space and in laminar space is this idea of base laminates, sub-laminates, and the differentiation between laminate definition by zone and the laminate definition by ply on the global model. I think a good example is that of looking at a simple panel. We have a base area, and then we have shear reinforcement areas going towards the center of the panel. And the way you can define laminates is either by selecting one zone, so let's take this external zone, and apply a given laminate in that position, or you can use apply-based definition, in which you basically define only the additional plies on the reinforcement areas. Now, CompoSIDE does support both approaches, but as the end results, what you can see, for example, when we create a laminate table using the definition by zone, is that we're going to end up with. Let's try to load the file. Just a second. So what happens is when you generate the okay, here it is, zone based. When you generate the laminate table, as you can see here, using a zone definition, what you have is basically 3 different laminate tables for the same product, and each defined to a particular zone. However, it's clear that the core, for example, is something that is shared across the 3, so are the first and the last ply groups. So that's not really an optimal way of defining those laminates. The other approach that you will see used a lot also today in the webinar is that of the ply definition, in which basically we define the base ply across the entire panel, and then we apply only selected plies to a number of rules to the geometry, so similar to the zone. But what this does is it basically gives you a clean laminate table. It is clean, it's consolidated alongside with definitions of the coverage, and you can also add comments and things like that. So you have a single table summarizing all the information, which is much cleaner and easier to then use and refer to. So this is something we'll use extensively in the webinar today with the modeling of the bulkhead. Okay. So let's go back to the presentation. Okay, here we are. So as I mentioned, just definition by zone 1, 2, 3 will basically give you the 3 laminate tables. On the other hand, defining a single laminate and application of rules to that geometry with then the sublaminates allows you to consolidate all the data in a single design and in a single environment. Report space is the module dedicated to the automatic reporting and versioning of your documents. It allows you to create a number of standard templates, but also to modify those in order to create custom templates for your organization. Integrated reporting are available for a number of modules, including the laminates, the sections, including reserve factor analysis, but also the bill of material and the yacht scantling report. All those reports can be created, can be issued alongside with a number of revisions, and can be shared via both HTML files and PDF files. In that sense, BOMGen is the model dedicated primarily to the bill of material. So we have the components, we have the materials, we have the laminates, we have the 3D models, and what we do is we calculate all of the surfaces, all of the areas, all of the weights, and also all of the prices associated to specific materials in order to give you a clean, summarized or as detailed as you wish report on the materials that are used within the project. Now, what we do include as well, if you remember, we mentioned earlier, you're able to customize your usage and wastage factors. So according to the manufacturing process that you have selected for given materials or laminates, you're basically able to also receive an estimate of how many materials are used in the process. For example, how much of the resins is being consumed and how much of the materials are wasted, so that may be cut off because of the geometry and so on. So that what we give you is the weight, surfaces, and material used in the final product as after manufacturing, but also the material that needs to be sourced in order to create that product. And similar to report space, you can basically issue PDF, HTML, and a number of revisions as your project progresses. One of the features we haven't discussed in the previous webinar is the ability to replace materials or laminates. So by just duplicating a product in bill of material in BOMGen, we can also directly replace any of the material used with other materials, any of the laminates with other laminates. That allows us to very quickly create comparison. For example, if you have carbon versus glass, or if you have a metallic versus glass or carbon structure vessel, you're able to very quickly estimate what are the upsides and downsides in terms of prices, performances, and so on. And finally, yacht scant, which was the object of the first webinar, is the scantling, is a scantling environment, is designed to handle sailing and motorboats according to ISO and GL certifications. But we also provide a pressure override parameter in case you would like to test different values or apply some of the ongoing changes those guidelines, such as, for example, multi-hulls. Yacht allows you to manage all your vessel components, so you can define a topology of the vessel in terms of, for example, hull, deck, or internal components and structures. But you can also bring in your own topology template via an Excel file, and also create and also automatically create all of the scantling requirements, so in terms of beam and panels, positioning and dimensioning, by importing again an Excel file formatted from your CAD design or your CAD environment. Alongside with the scantling requirements, you can also include full three-dimensional elements, so you can have full bulkhead, you can have a keel structure, you can have a rudder. Those will not be part of the scantling report itself. They are, however, managed within your vessel structure, so allows to keep all the components together, and will be picked up by the bill of material generation tool in order to include all of those in a single report. And again, similarly to report space and BOMGen, all the scantling reports are automated and integrated within CompoSIDE, so that when you define materials and laminates, those are directly available to you when you are assigning those to your panels or your beams. Okay, I think that's it for the introduction to the main modules. It'll be now time to almost to jump into the bulkhead design, and I'll leave it to Jonathan.
Okay, thanks, Lorenzo. So before we jump into a live design, I just want to go through what CompoSIDE can help you with within your vessel and products. So typical uses of CompoSIDE is from preliminary design. As Lorenzo said, this is the focus of the first webinars, is using YachtScan to define the basic hull laminates for your panels and your beam laminates for your hull beams, deck beams, etc. Then we go on to detailed design. So this is what we worked on last week. So this is, for example, we did an engine grillage keel structure. So this is detailed design using 3D grillage, pretty basic but very powerful, using sectional space and FE space. So what we're going to focus on today is the advanced modeling. Now, we're going to focus on a bulkhead today, but this can be any component on your yacht, any component in composite or metallic designs. So this could be a bulkhead, the main sheet structure, so anything you've got penetrations in, you're a little bit concerned about adding too much weight, you want to optimize it, you want to add patches in the right areas, you want to add tapes in the right areas, and you really want a quick way of iterating with this and get a cost and weight straight out of your design. So if you want an automatic cost and weight, this is where we come into BOMGen. This is our automatic bill of materials generator. This will take all of the data which we have used to analyze our bulkhead into the BOMGen module, collate it all nicely using bill of material factors, usage and wastage factors, and put it into a nice concise report for you within report space. So as Lorenzo said earlier, we can create bill of materials reports from a standard template that you create, or you can use one of ours, and also a certification for your vessels. So if you've got a whole vessel from YachtScan, you can send that off to the certification body and ask for that to be certified. So moving on to the bulkhead, this is a typical bulkhead that we designed within CompoSIDE. Fairly basic. Let's go through the workflow that we do in CompoSIDE. So in project space, we have our project and vessel setup. This is where we set up our topology. This is where we organize our safety factors, our analysis settings and bill of materials factors, all in one place. We can also set them as default for all of your company, all of your projects, or you can do it for individual products. So if I have in a project 2 different versions of boat, I can change the bill of materials factors to see how much difference it's going to make. Okay, so we've got our vessel set up, our topology imported. Next thing is to choose our material selection. So this is always quite a big thing in composites. Maybe you want to choose a glass and a carbon and you want to compare them against each other. Very easy to do this within CMDB or within other modules within CompoSIDE. Next step is to find our laminate. So this is quite a key part of this, the way that we're going to design our bulkhead. So as Lorenzo mentioned earlier, explained earlier, the zone and ply based way of modeling composites. We're going to stick with a ply based. It's a lot easier. It's very easy to work with in CompoSIDE, and you can easily modify it, update it, because it's not defined to restricted to any geometry. So the next step is to import or create our geometry, add the loads and boundary conditions. We can do this all in one step. They're not going to change, so do that in the first step. Then we create our rules and local coordinate systems. So once we've got our laminate defined, we know that we're going to have X amount of tapes on the port side, side tapes. We're going to have X amount of tapes on the top tapes, a certain amount of compression tapes in the bottom of the bulkhead, and a certain amount of tapes around the hull. So we can set up these rules. We know the width, or the first initial width of those tapes, but we can change that later very quickly. Then we assign our materials and laminates. So we can assign those laminates that we define in laminate space, or we can assign a stack up of materials within FE space. Personally, I like to do it within laminate space, so then it's all set up. When you change something in laminate space, it will automatically propagate through to FE space. Then we analyze our results. So this is where our optimization comes in. If we've got our first set of results, they're probably going to be either optimistic or pessimistic. So we need an optimization loop in here. As I said, within laminate space, it's very easy to just update the laminate, and then everything will automatically update downstream. You can just remesh, hit calculate, and get your next set of results. So yeah, very easy to optimize and update your laminates, loads, boundary conditions, and geometry. And then the last step is getting your weight and cost out. So this is your documentation. We want a bill of materials with a cost and a laminate table for our bulkhead. So let's jump into CompoSIDE. So for those of you who are new to this webinar, this is the CompoSIDE desktop. In general, we work from left to right. So as I mentioned in project space, this is where we set up our project settings. So as you can see in here, I've got a few different products within here. If I close all my materials, my laminates, my beam sections, my reports, I'll get to my products. So this is where we can organize how our products how you want. So I have a 60-foot sailing yacht in here, and this is just a keel design. I also have a 60-foot sailing yacht within a yacht scant model. So I can organize all my FE models within here, or I can create a different separate product. It's really up to you how you prefer to work. Okay, so we've got our vessel set up. Our topology is defined. We've sorted it in the amount of folders that we think is suitable for the project. Next step is to select the materials. So for this, we jump into CMDB, and you can see automatically that I have my project materials. So this is my project materials, which I've already selected for my 60-foot sailing yacht, my 60-foot motor yacht, and I've already organized this from my huge list of materials within my database. So as Lorenzo said earlier, our CS material library is the CMDB add-on, very useful if you want to just grab a ply and see how it compares against some other plies. So I've grabbed all of my materials from that library. and drag them into the project materials. So on the left here, I've created a couple of material selections. And in here I've got my bulkhead materials. So I want to keep one selection for my bulkhead. You can do this for example, the hull, the deck, bulkheads, any kind of different components, if you've got different selections of materials that you want to use. So in here I can use these materials in other softwares. So I can export these to Nastran, OptiStruct, ACP, or just to Excel. So I know some of you may use Excel spreadsheets still. You can easily export these properties and use CMDB as a material database. So you've got the same materials if you've got quite a widespread engineering team. Your materials team can update or add materials into the CMDB library, where you can link it directly with your spreadsheets. So I'm going to have a look at the scatter plot. I want to compare these materials, let's say for density versus tensile modulus. So this gives me quite a nice, I've only got 3 selections, so it doesn't look very impressive, but it gives me a very nice comparison of all the different materials. For tensile modulus versus tensile strength, for example. So any property that I've got within CMDB I can compare, and it's not just for plies, so I can compare plies versus woods, plies versus metals, all of the materials, plastics, plies, matrices, any cores. Very easy to compare these all together. So if you want just a rough understanding of where these properties are against each other, scatterplot is a very good way of viewing this. Okay, so I've got my material selected. Next step is to create a laminate. So let's jump into laminate space. Okay, so I have my laminates in here. Again, I've got my topology broken down into a few different folders. My 6-foot crude eraser, I've got my bulkhead, deck, and my whole laminates in here. And I can have a look at my sub-laminates. So you can see in here that I've got a breakdown with sub-laminates of tapes, compression tapes, bottom tapes, basic bulkhead laminates. So let's go through how to create one from scratch. So let's call this bulkhead laminate. Now we can choose the fiber type and manufacturing type. This comes in later within BOMGen, and this will automatically take these values for your wastage and usage factors. So we can click create, and then this will open an edit window. So we can create plies in here, add a few plies. So I'm going to create a basic laminate for our bulkhead. It's just going to be a woven carbon at 0.90, add this in, and then a biaxial, so XE, 300 gram, and I want this at 45. So if I want 2 plies of this, very easy to add it in. And let's go for a core. So let's pick a T10 by 3A, 20 millimeters thick, and we can orientate this at 90 degrees, for example, and we can add this in. So this is a symmetrical sandwich. I need to mirror it around this this core, so I can choose the sequence type to make it symmetric odd, and it will automatically mirror it. So anything that I change on the top will be mirrored on the bottom. So you can see that later on you will see the complexity of our bulkhead laminate. This is very, very useful. So if I change any of the tapes on the top, it will automatically mirror them to the bottom, saving me loads of time, saves me from making those errors that you may make. So this is my basic bulkhead laminate. What I'm going to do now is I'm going to add a sub-laminate, and I'm going to call this additional patches, and create this. So what I'm going to do here is, if I uncompress my stack up, so in my basic bulkhead laminate, I don't want these plies. These are additional, so all I have to do to have an additional patches laminate is just select them and add them to my stack up. Now this will create a different section, a different laminate which I can check the engineering constants and laminate properties for, and this will give me a different generic data. So you can see that I have, for this sublaminate, I have a different top skin total weight, core weight, than I do have with my bulkhead laminate, my base one. I can also add plies in here as well, tapes in here. So if I want them in between this woven and this biax, all I have to do is add a ply, and let's say you see standard modulus. I want 5 of these. I can add these, and then I can assign these to a different sublaminate if I wanted to, but I'm going to keep them on my base laminate. So it's very easy to create quite a detailed, complex laminate with a few different sublaminates, different tapes, different patches within here. So once I save and close this, CompoSIDE generates all of the engineering constants, all of the engineering data, starting from generic data, so thickness, weight, density, cost. You can get a good idea of your different sublaminates. So my additional laminates going to be a little bit thinner because I haven't got those tapes. Check out the density, weight, quite a good understanding, gives you a good feel of your laminate. And then we move on to our engineering constants. So this is our in-plane, out-of-plane constants, our stiffness constants. And we can also have a look at the ABD matrices if you want to. Then we go into our allowables. So this is our allowable bending moments based on different failure types, different direction moments, top skin, bottom skin, the different moments that apply. And it will give you a detailed breakdown of your failure sequence. So based on the different failure modes, you can see if I want my first fiber failure mode, I know that it's going to be this ply under this moment, and this is going to be my critical strain for that bending moment. Now we can also have a look at the sandwich stability or apply loads directly to this laminate, but sometimes if you're going to create a model anyway, I tend to create a model, extract the loads and bring them into my laminate. So I can do that automatically from FE space and then optimize my laminate maybe within laminate space once I've brought those loads in. Okay, so this is my basic bulkhead laminate. It's quite complex, as you can see. I'll hide this generic data. So you can see I've got quite a few sublaminates, quite a few tapes and orientation sets. And orientations. So if I want to send this to the shop floor to give them an idea of the stack up, I can just hit laminate family to Excel, and this will just send this laminate family with the sublaminates and the tapes and the group to my laminate to Excel, print this off, put it in the drawing, whatever you need to do with it. So it takes no time at all to generate documentation from CompoSIDE, and it's quite neat, quite tidy, and saves you quite a lot of time in deliverables and conveying information. Oops. Okay, so I have my laminate defined. The next step is to jump into FE space, where we need to define our geometry, our laminates, our rules and coordinate systems. So let's jump into FE space. And in my cruiser racer, I have my bulkhead model. So once this loads, you'll see how simple the geometry is, but you can see how I've defined the tapes and batches, etc. So I've imported this model via step file. I've just dragged it or grabbed it from my 3D file, imported it as a step. But there are a few other ways of creating this. If you just have the geometry, you can create a surface from a plane and a small sketch that you can import via DXF or create manually in here. So there are a few ways of doing it. You can also create beams from template, shells from template, or shells from extruded sections. So there are a few ways of doing it. Okay, so I have my geometry. The next thing to do is to apply my rules and coordinate systems. So within my rules, I have a few different rules here. You can see I've got my hull tapes, my port side top tapes, my starboard side tapes, my starboard top tapes, and you can see that it's all around the mesh. So if I look onto the bulkhead like this, I've got my different tapes where I've got my additional patches, my additional capping. These I'm all going to apply into my laminates. So it's very easy to create these. And if I want to modify this, say if these starboard tapes I want to be 400 wide, very easy, automatically updates, and then you can remesh, recalculate. So let's change this back to 300. And then the next step is, so we want to create orientations for our plies. Now these are these small coordinate systems here. What I've done is I've created a coordinate system, Cartesian coordinate system, based on this point, and I've used this geometry to align this coordinate system along the x-axis. So this is along the fiber direction. So I've created these for these top tapes and the side tapes, and then the capping and the bottom tapes along the here. So I've got my rules, I've got my coordinate systems defined. The next thing is to apply my laminates. So I've got my bulkhead laminate straight from laminar space. So let's go into this. So once you choose your surface, you can then apply your stack. So this is automatically linked with my laminar space laminate. And if I compress it by material, you can see it's exactly the same as it is in laminar space. And all I've done is I've used these rules and coordinate systems to apply it to a certain strip of bulkhead laminate. So I've assigned my rule and my orientation set. So it's starboard top tapes, and you can see the orientation of these tapes following the edge that I've defined it as. And it's very quick to create it or apply these rules and coordinate systems to these plies. One by one, you can do it by groups. So when I save and close this, and I show you my mesh, so mesh thickness, you can see that I've got all of my tapes assigned here. I've got my additional patches here, and if I unlock this, you can see that I've got my my capping defined here. I've got my hull defined here with my hull tapes. So all of my reinforcement is done within rules and coordinate systems. And if I want to change the width of my tapes, again, rules, remesh, and then calculate again. So this is a very parametric model. It's not defined by any geometry, any surfaces, so it's all ply based. If I apply a laminate to a certain strip, it will take it as that ply within that region, within one laminate. So later within BombGen, it will take one laminate and just work out the amount of area that those tapes or patches are going to occupy, and then automatically create that weight and cost for this bulkhead. Now, I've got my tapes defined, my load cases defined. So in here I've got my load case, which is master compression, basically simply supported at the top here. So all of my load is within the bulkhead. I want my master compression to be taken fully by the bulkhead. And I've sent this away to the server. You can see here that it's taken a few seconds to send away and calculate. So if I load a previous result, it will bring this in. Now what we can do with these results is we can save these. So by clicking the lock, and we can rename these by saying this is iteration 1 or whatever. So I've got that saved and defined within here. I know where it is. I can grab it. Someone else can go into that model and grab that calculation. Okay. So I've got my bulkhead deflection. I can also have a look at my applied forces and reactions. So I can have a look at my reaction forces, show them as a vector. So yeah, I can sanity check my model before I go into a little bit more analysis. So from here we can then jump into the reserve factor for the shell, and you can see that it's grabbed all of my my plies. I can hit calculate, and it will calculate the reserve factor based on the failure type that we've selected in the top here, so by minimum or by fiber, by resin shear, etc. So this would usually take a few seconds. It's calculating all of my plies. I've got quite a few plies in here, but it shouldn't take too long. And then it will bring me back a reserve factor plot for my bulkhead, which will give me a very good understanding of where I'm failing, where I'm probably a little bit too heavy on reinforcement or plies. And then I can optimize this a little bit further. Okay, so this is taking a few seconds.
I think one of the advantages of working with the ply-based approach is you're also able to visualize the results ply by ply globally on the model itself. Mm-hmm. And hopefully as Nine finishes to load, we'll be able to show that as well.
Okay, so let's refresh the page. Okay, so let's jump back into FE space. And a great thing about CompoSIDE within FE space is I have my results already ready. So once they're sent off to the server, you don't have to save them. It's automatically in the tree. You can just grab them. So if you can send away your model to be solved, you can close CompoSIDE and then you can come back and it will have solved your model and have your results. Okay, so let's have a look at the element results. So just my strains from my membrane and bending, and I can have a look at each individual element. So in my bulkhead, let's say I want to have a look at my starboard side tapes. I can just click on starboard side tapes, and it will bring up just those tapes, and I can have a look at my strains within that line. Okay, so you can see here that I've got my results. Not quite sure what's going on in that corner, but you can see that I can have a look at each individual ply. I can have a look at any, let's go for, in my base laminate, I have my additional patches. I want to have a look at the strains in here. So, this loads. You can see that I can have a look at all of my strains within my hull, within my deck, and really have a look at these results ply by ply. So you can do that with the strains, with the internal forces, with the reserve factors, etc. And we can also have a look at the principal strains if you want to understand the work, the load flow within this bulkhead. Okay, so that's the generic way of creating panels with reinforcements. Next thing we want to do once we're happy with our bulkhead is to create a bill of materials from this. So within mesh I can see my mesh properties, and while I'm doing my design I can have a look at the weight, which is just calculating now. Take a few seconds. It's just grabbing the weight, understanding where the weight is and all the plies. And then this will be used later in BombJet. It's taking a few more seconds than I expected. Okay, let's just jump directly into BombGen. So what we can do is go into BombGen. And in my Cruiser Racer, I want to update. So this can just bring all of the materials in here. And I've got my bulkhead laminate. So this is the total. So this is all of the boat. I can choose and pick which elements I want in my boat, which elements I don't want to be shown within reports or bill of materials. But this is just within bulkhead. So you can see I have my weight breakdown and then my total ply breakdown. So as designed, so this is just dry, just with the basic resin, basic fibers, basic cores, up to the total weight, which is the cores with resin consumed, any offcuts I may have around the side of my panel when I trim my panel, and these are all taken into account. So this total weight is the total weight of materials which has to be ordered, which is a very nice, easy way of ordering materials and defining to your manufacturer, I want X amount of materials. And then from this we can create a BombGen report using our template or one of your templates. You can create them very easily. I'm just going to create one, all components without cost. And this will bring all of the data into one nice PDF or HTML report, which you can version, you can issue. So if you have one report as P1, preliminary design, you can then issue the document again as P2, write any logs in your issue log, and this will automatically be documented within CompoSIDE. So you have full traceability of when and what you're doing to those reports when you're issuing them. So if I generate a PDF, we can just go through very quickly a BombGen report. Okay. Okay, so this is my report. I've got a product summary giving me a breakdown of all the weights of materials, weight estimate, a component summary. So for my hull, I know the amount of tapes that I've added into my inner skin or outer skin, my deck group, any components that I've added, my capping, the amount of plies, the amount of weight, cost, etc., and into my bulkhead. So this gives you quite a detailed breakdown depending on which report you choose. Okay, so within CompoSIDE, if you're fairly new to it, or you're stuck, or you want to know a few things on how to get places, what's the best way to approach something, there are a few ways to do this. So we can go into Tech Docs, which gives you a breakdown of all of the functionalities within CompoSIDE. We can go into tutorials, which will give you a module-specific list of tutorials. So we're in BombGen at the moment. You can see that I have a tutorial list which is specifically for BombGen. This will change for each module, or if you're on the dashboard, you can still click tutorials and you get module specific. Another way to get help is to chat with us directly. So you can see down the bottom here we have CompoSIDE chat. We're offline at the moment, but this will get sent to our emails and we'll get back to you very, very quickly. So if you've got a quick question, how do I do this, how do I apply a rule, or how do I apply a tube rule to an edge, you can just send us a message and we'll get back to you as soon as we can. Okay, so let's jump back into our presentation. Okay, so we've set up our project and vessel, we've imported our topology, or created our topology manually within CompoSIDE. We've created our materials, or chosen our materials, and then we've used these materials to create a laminate, where we've applied this to our bulkhead, applied it to the geometry, created rules, local coordinate systems, and then we've done a short optimization loop, which is automatically updated, and then we've created documentations from this. So there are a few ways of creating bulkheads or advanced design within CompoSIDE. These are a few examples of successful marine projects within CompoSIDE. So this first one is a 116-foot yacht. This is at the top left. You can see we've done a bulkhead model. So this is including the keel grillage. We wanted to understand the load paths based on the different stiffness of the elements within this structure. So this is another way of modelling a bulkhead using beams as side tapes and transverse beams. The next one is a 100-foot yacht. So again, this is a beam model, but you could have used a shell model similar to the way that we defined one today. This is a main sheet structure on this 100-foot yacht. And then we have, this is a good example of detailed design within CompoSIDE. It's a 45-foot high-performance racing yacht. Everything needs to be as light as possible, as stiff as possible. So you can see on the left that we designed a lifting keel gantry, which when they're racing, they want to be minimum weights. So this is really pushed and helped with the use of CompoSIDE. So a high-speed powerboat. This does about 45-50 knots. Has 1,500 horsepower and engines in total, so quite a highly loaded structure. This was analysed using a frame grillage, and again, this had to be very, very light, very tight weight constraints, and quite a tight deadline for the project. So CompoSIDE really helped with the deadline of this. And a 76-foot sailing yacht. So this is part of a deck that we analysed. This is using a step import, and we created this using a shell model. And we applied tapes and patches to this to strengthen it up without increasing a lot of weight. Okay.
And alongside the vessels or detailed component design, CompoSIDE can also be used by let's say materials manufacturers as part of the enterprise solutions. What you see here is a system basically designed in collaboration with 3A for the automated bill of material generation for marine vessels. So the idea is, as part of 3A offering, prospect customers can log into a special edition of CompoSIDE, just select the type of vessel they're most interested in. Is it a sailing yacht? Is it a motorboat? And the technology they would like the vessel to be built in. So it can be PET, PVC, it can be T10, can be balsa, carbon, glass, and so making those combinations, they then select the size of the vessel, and what this system generates is an automatically generated bill of material that will help you to basically establish all those weight, quantities, and costs for the materials on different technologies as provided by 3A. So there is a recording available, as for all our webinars, is here on the CompoSIDE YouTube channel. And finally is a recent endorsement very early this July, so with our agreement with User and Brolic Design and Engineering, where CompoSIDE was selected to support the design activities and help them to create faster cycles for design and structural performance of part of or entire yacht structures. Okay, so in conclusion, CompoSIDE is a platform that can hopefully allow you to improve your workflow efficiency. Is a system which is easily accessible via any web browser. As you can see today, is scalable, meaning you can go from 2 to 10 users within the day if you have to, and back to 2. So it's really something that can follow your engineering requirements and the growth and downsizing of your teams. The integrated approach can save days and days of engineering resources per project. Just looking at the bill of material generation, laminate table generation, all those things that are automated and you don't need to spend time on your shore you're sure that the quality and the consistency of the deliverables are impeccable. And hopefully all of these combined can help you to reduce your project costs and make your company more competitive within the marketplace, either in provision of the services or in building of some of those components. So all of the projects that we've explored in the past month are now being made available in CompoSIDE. So anyone who is registering for the 30 days free trial will be able to just request us access to those to this particular project, and or actually you've just been able to download it almost directly and to copy it into your own database. And so that will give you access to the entire marine project folder. That includes the laminates, the cruiser racer, the motorboat, kills, griddle, and bulkhead. So you're free to review those vessels, review the components that have been designed, and to experience yourself by making new design or benchmarking designs that you already made in the past. And if at any point during the trial you get stuck, there is a dedicated support and training page and activities. So Jonathan mentioned earlier, we have close to 100 video tutorials about the different activities you can have in CompoSIDE. A live chat is a good option for a quick question. Otherwise, support ticket, FAQs, and webinars such as today can be helpful to review some of the questions. Alongside with the support, CompoSIDE also provides dedicated training. So if you have new components you want to design, new structures that you want to evaluate, we'll be able to support you in those activities, either via training you to perform those calculations or by performing those calculations in your through activities such as engineering services and so on. Okay, so we're now at the end of this last webinar. We have, well, a couple of minutes past the schedule, but I think we can potentially take a couple of questions if needed. I've seen one or two coming through. Let me see. So we have a question whether we support academic usages. So yes, we have both commercial and academic offering. For commercial one, everything is detailed on the composite.com/pricing. Academics, we tend to do that one by one according to whether it's a project, a class teaching, or so on. So we'll get back to you on that. There was a question on the terms of subscription services. With CompoSIDE, since it's web-based, we also do 3 months based subscription. So if you are an independent consultant or small engineering office that only uses composites within, let's say, a few of the project during the year, you can use it on a project by project basis. So you can actually license it for 3 months. So your project is done, and then all the data is basically stored securely. You come back 9 months later, you're basically able to pick up all of the data and get back into CompoSIDE without having to maintain expensive software. Okay, so we're getting to the probably end of the time allocated today. We would like to thank you for your participation throughout this month. I know there has been quite a few of you attending many of our webinars. It's been quite an intensive schedule, but thanks for attending, and hopefully we'll see you soon on the CompoSIDE platform. Just a very quick reminder. If you have, if there is any feedback you'd like to share, there is a short survey will be coming up as soon as you close the GoToWebinar interface. I appreciate your answer. That helps us to make our webinars more interesting and focused on your activities. I see a couple of questions coming through, so we'll get to those directly and personally just after the presentation. Okay, thank you very much for your attendance again. Have a good afternoon. That will be all for us.
Thank you, everyone.